Hello, welcome back. Let's take a look at this example here where we want to compute the null space of a particular matrix. So I've taken the matrix from the last video, the row and column space video, and I want to compute the null space. And so the way that we're going to do that is, first off, we need to solve the homogeneous system, AX equals 0. Right, so let's remember how we do that. So we have our matrix A with the given reduced row echelon form, and if we're solving with a 0 column at the end, well, augmenting by 0 isn't going to really change anything here. So ultimately, from our reduced row echelon form, we learn that, let's call these x1 through x4, that x1 minus x3 equals 0, x2 minus x3 equals 0, and x4 equals 0. So out of this, we know that x3 is our free variable. So we could say x3 equals t. All right. And then x4 we keep at being 0. x2 equals x3 if we solve for x2. So x3 is the same thing as t. And x1 similarly is also equal to t. Alright, so once we solve that, we want to write our solution in vector form. So the way that we're going to do that is we're going to just isolate each of the parameters. So in this case there's only one. So our parametric form, or our vector form, some of you noticed on the practice exam an example of this. So this is equal to extract that parameter, and that's times each of x1, x2, x3 have one occurrence of t, so we'll put a 1 in each of those spots. x4 has 0 occurrences of t, so we'll put a 0 there. Now, let me just say real quick, if this was like a 2t here for x1, this would have been a 2. Alright, well, let's get rid of that because it's not. And similarly, if we'd have another parameter here, say x4 was s, we would add a second variable. Alright, let's say this was 5s, 2s, something like this. We'd get 5, 2, 0, 1. Something like that. Alright, so let's go ahead and erase all these because we don't want to give the wrong answer, but I wanted to show you, illustrate how we would deal with that. Alright, and then our final step, our 3, is actually just write the basis. It's actually already there for us. It's this vector right here. You'll have 1 corresponding to each of your parameter variables. So our basis for the null space, in this case, would be 1, 1, 1, 0. Right. Which we could also have written it in row form. Whenever we're working with vectors, we can write them in row or column form because it's a vector, and that doesn't matter which order we're writing it in. Versus a matrix, it matters if it's a column matrix or a row matrix, because matrices have dimensions. Anyway, that is everything for that exercise. Let me just point out real quick that, again, however many, actually let's write down the dimension. Alright, so the dimension of the null space of A is 1 because that's the number of stuff in the basis, so we'll also say that that's the nullity of A. These are the same thing. Alright. And so, how could we have seen that off the bat? Well, the number of free variables is equal to the dimension. So this equals the number of free variables. Versus the rank is the number of non-free variables, the number of leading ones. remember that from last time. Equals number of leading ones. All right. Excellent. So that is that. That's how you compute a null space. Let me know if you have any questions. Otherwise, have a good one. Bye-bye.